Alright guys, so I'll be doing this question. So all the manufactured devices and machines fall into well, filter work sooner or later. Suppose that the failure rate is exponential, parameter lambda. So the first question asks, what said measurement show that the probability that the time to failure for a computer memory chip in a given class exceeds 10 to the power 4 is e to the minus 1. The one is exactly the value of parameter lambda, right? So the first thing we need to take into consideration is the PDF for exponential distribution is lambda e to the minus lambda x, where x is more than 0. As a PDF, right? The CDF, which is capital F of x, which is the probability x is less than or equals x, is 1 minus e to the minus lambda x, right? The safe could also be x less than x because it continues. Right, so both equal to the same thing, right? Right. And then this one here, the probability x is more than x would just be e to the minus lambda x. So these are some equations I could use in some question. So with respect to the question, we have to do the tolus or the ones the probability exceeds. So exceeds means it's more than 10 to the power 4, right? So that basically means the probability x is more than 10 to the power 4 is e to the minus 1. All right, so the one to calculate the parameter lambda. So first thing we could try to create or to bring in lambda is using one of the equations. So we have the equation for the CDF, which is this one here, and we have the equation for this one here, which is the opposite. All right, so with respect to what we have this right. All right, so we could bring in the CDF equation. All right, and we could use that form of it. So to get the CDF, it will just be 1 to the probability x is less than or equal to 10 to the power 4 in this case, will just equal to 1 minus the probability x is more than 10 to the power 4. Right? So if you want some less than or equal to something, you just kind of carve out what more than it's already. So that's where we get this equation from. So now we could plug and play. We know the value for this. So 1 minus e to the minus lambda x. And 1 minus, and the value of this is e to the minus 1. So we could cancel the ones and the minus signs. So we get e to the minus lambda x is equal to e to the minus 1. And once you have the same basic, it equates with powers. So you'll end up with minus lambda x is equal to minus 1. And what we know x is 10 to the power 4. So now we can cancel these negatives and solve for lambda. And you'll end up with lambda being 1 and 10 to the power of 4. Right, so that was the answer there. Right, so yeah, that was that. If you wanted to, you could have used this form of it because I really way have already. So I'll do it in this corner here. So the probability x is more than 10 to the power 4 is equal to e to the minus 1. So we know this is e to the minus lambda x, which is e to the minus 1. You clearly see it reach the same spots you were at using the other form of the equation. Right? So you have two ways. So once you go through the normal steps that I did before, equating the coefficients, sorry, not coefficients, powers, minus 1. And once you solve, you'll end up with the same answer. So you have actually two ways. So this way is working with the CDF, and this way, well, the opposite of the CDF. So 1 minus the CDF. All right. Yeah, so that was the first part. So part B says using the value for lambda determined before, which is in part E, calculate the time x0 such that the probability that the time to failure is less than x0 is 0.05. Okay, so we said that the probability x is less than some value x0 is 0.05. So this here we could use the CDF because it's continuous. We don't necessarily have to have the equal next to it. So we could just use that form of it. Right, and we know the equation for this. 1 minus e to the minus lambda, in this case x0 is 0.05, carry across the 1, so you get minus 0.95. You cancel the negatives. So in this case, we don't have e on both sides. So all we need to do, we need to learn both sides. So we are not going to learn e to the minus lambda x0 is ln as 0.95. And since ln and exponents are opposites of each other, they cancel. So you just end up with minus ln x0 is equal to ln 0.95. And then lambda we know from before. Yeah, lambda we know from before is 1 on 10 to the 4. X0, we don't know. Right? Yeah, the minus, right? So now ln as 0.95. Right. So 10 to the power 4 x0, and ln of 0.95 is minus 0.0512. So the negatives will cancel finally. And let's have to divide by that. So divide by 1 on 10 to the power 4. And you'll end up with x0 will equal to 512.93. And in this case, x0 was time, so I believe that would be years, but that'll be x0. Alright, so that's the end of that question. Things to keep in mind are these equations here. Alright, and also one last thing in terms of writing the parameter for the random variable for exponential, it would just be x follows exponential, and the parameter for it is lambda, right? So that just side notes. Alright, and that is the end of that question.